Today, I have a practice lesson on physics. This is about the magnetic force on a conductor. This is the question. I have four very long wires. 1, 2, 3, 4. These four long wires are all parallel to each other, and they form a square. The distance here, distance here, distance here, distance here are all equal. It is a square. The current in each wire is 15 amperes going out, going out, going out, going out. What is the magnetic force on number 1 conductor per unit length? Because each conductor is very, very long, so it doesn't make sense to ask what is the force on the whole very long conductor. So we are only asking what is the force per meter of conductor 1. Okay, that is the question. Conductor 2, because there is a current, therefore conductor 2 will create a magnetic field surrounding conductor 2, and the magnetic field, of course, is passing through conductor 1. Similarly, conductor 3 with current in it will also create magnetic field at the location of conductor 1. Conductor 4 will also create magnetic field at the location of conductor 1. Therefore, what is the magnetic field at the location of conductor 1? The magnetic field is the sum of the field produced by conductor 2 and produced by conductor 3 and produced by conductor 4. It is a sum. But it is not the sum of the magnitude, because magnetic fields are vectors. Therefore, you have 3 vectors. 1 due to number 2, 1 due to number 3, 1 due to number 4. You have 3 vectors to add, and the result is the resultant magnetic field. Once you have the magnetic field at the location of conductor 1, then you can find the force on conductor 1 per unit length by using the force formula. So let's begin with finding the magnetic field B due to each conductor number 2, number 3, number 4. Okay, we'll do that. To do that, I need a formula. Okay. This formula is the magnetic field produced by a very long wire with current I at a distance R from the wire. So let's consider number 2 wire. Number 2 wire applies this formula. I is 15. What is R? R is the distance between 1 and 2. What is the direction of the magnetic field? Right-hand rule. Current is out. So, this is my thumb is the current direction. Right hand. Therefore, the magnetic field is counterclockwise. At the position of 1, the magnetic field is down, right? Let me do the right hand rule again. Current is out, right hand, therefore here, the field is going down. Do you follow? Out, the current, right hand, current is down. And this magnitude is given by this. So let's carry on. What is mu 0? Mu 0 is 4 pi times 10 to the negative 7. So I have this. This is mu 0, 4 pi 10 to the negative 7. Cancel the pi. Simplify 4 and 2. So after cancellation and after simplifying, my formula becomes this. All right. And in this, I is 15. What is R? R is from here to here, the distance. The distance in the question is given to you. Okay, but it's here. Okay. This is the distance of the square shape. The side is 8.5 cm. So I can put 8.5 cm here, but you need to change it to meters, right? Okay, so this is my B. We will work out the numerical value later, but this is the B. Now, what is the magnetic field produced by 4? The current is out. Right-hand rule. What is the B at this position? Right-hand rule. This is this way, right? The distance is still 8.5. The current is also 15. Therefore, the magnitude is the same. Magnitude is the same. So I have two magnetic fields already. I have another one due to this. But remember, we need to add the magnetic field due to this one, due to this one, due to this one. But due to this one and due to this one, they have the same magnitude. Let me add this first before I add the magnetic field due to 3. So let's add this one and this one. The magnitude is this. The magnitude is also this. You add vectors, parallelogram. These two vectors are perpendicular to each other. So I have a rectangle. And because the two sides are equal, my rectangle is very special, is a square. And the diagonal is the sum of the two vectors. And the diagonal makes 45 degrees with each side. All right? So this is 45 degrees, 45 degrees. All right? How long is this side? Remember, 45 degrees, 90 degrees, the right triangle, the hypotenuse is square root 2 times the perpendicular sides. This is square root 2 times this side. Therefore, the magnitude is square root 2 times 2 times 10 to the negative 7 times I divided by R. You get it? Do you follow? Do you follow? This is a 45 degree right triangle. Okay, this is this. Now, we want to add another vector due to this long wire. Current is out. Right-hand rule. This is a square. So right-hand rule, the magnetic field is this way. Because this distance this is the diagonal of the square, and this is perpendicular to the distance, right-hand rule. So this is 45 degrees, the same direction as this one. So, now you see why I add this and this first. Because I add this and this, the result is this direction, and the magnetic field due to 3 is also in this direction. So, you just add the two magnitude. Add the magnitude due to the 3 with the magnitude of the sum of these two. All right. So I need to erase something. Okay. Let me erase this top one. This is B after cancellation and simplification. Okay. So for B due to 3, B due to number 3 is 2 10 to the negative 7 I R. Now this R is this distance. How long is this distance? The R is this R. This R is 8.5. Is this R times square root 2. Now this R is 8.5 cm. This R is 8.5 cm. So my R is 8.5. But for conductor 3, the distance is the diagonal of the square, which is 8.5 times square root 2. Now, I want to add this, no, here, I want to add this to this. So, finally, I have, let me erase this, all right? So once I have this, I can erase this so that I can have more space to carry on the next step. So resultant B is B due to number 2 plus B due to number 4 plus B due to number 3. And number 2 and number 4 add together is this now. And B3 is B3 is is this. B3 is here. So it's 2. Do you follow? I first add the magnetic field due to conductor 2 and the magnetic field due to conductor 4. I add them together because they have the same magnitude but perpendicular to each other. So I add this, I get the diagonal, which is this. And this, the direction of this, is the same direction of the magnetic field due to conductor 3. So I just add the magnitude. The magnetic field due to 3 is this. The distance between number 3 and number 1 is the diagonal. Therefore, the distance has a factor of square root 2. So I add these. So let me erase this so that I can do that. Or maybe I can carry on here. There are common factors here. This part and this part are the same, right? So I can factor out 2 factor of this and leave this in the bracket. Okay. Then I put in numbers. Current is 15 amp. Distance is 8.5 cm. Convert to meter. All right. Don't forget, we must use meter. All right. Okay. Let me erase this. So this is 15 amp, 8.5 cm. Change it to meter. This is meter. And then, let me do common denominator within the brackets. Okay, this is 2 plus 1. Once I have this, the next is to use your calculator. Use your calculator. And I did that. So what is the final result? Okay, the final result is if I round it, because I am considering the force per unit length, therefore my final answer has a unit Newton per meter. And this is my final answer. Just use a calculator for this part. So that's the answer to this problem. To do this problem, you need formulas. One formula is the magnetic field due to a current. Oh, this is not the final result yet. This is just the sum of three magnetic fields. What is the force? I think my answer is not quite right. So let me erase this. This is a force, but I haven't got a force yet because this is the B. Okay, no. This is a B. Okay. The final B. The B resultant. This is a B resultant. The B resultant. I need a force. The force is I L B. You need this formula. You need this formula to find the force. I is the current in conductor 1. In number 1. L is the length of number 1. B is at number 1 due to number 2, number 3, number 4. Okay. Everything is at the location of number 1. So let me erase again. Very sorry, my whiteboard is too small. I hope you follow each step. Okay. So F is, I is still 15 amp. The length of conductor 1, because I want unit length. Per unit length is 1 meter. The B is this. This is the B now. Now this is my force. Yeah. Sorry, I forgot. This is the final B, not a force. Force, you have to use this formula, ILB. And then you use a calculator. The calculator will give you the answer. My final answer is correct, but it is here, not there. Yeah, here. So the final answer is 0.00112 and Newton per meter. Okay? So you need to remember this formula. For force, you have to memorize this formula. And also you need to memorize this formula. B is mu 0 I 2 pi A, okay? 2 pi R. You need these two formulas, this formula and this formula, to get the final answer. And also, don't forget the right-hand rule, because B is a vector. B is a vector. The right-hand rule. Actually, this formula is also a vector formula, but I'm talking about the magnitude. Actually, this is a cross product of two vectors, but I'm not going to say any detail about it. So, that's the solution of this given problem. Okay. I got this problem from my student. He is right now at a university. So this is a university level physics practice problem. Okay, that's it for this lecture. Thank you for watching. Goodbye. See you next time.